so that we could use the same suite of related products to answer multiple needs and questions. And the staff have been really helpful as well. So briefly, the goals of the project were to map, quantify, and describe the location of our key habitats, the relative condition of the key habitats, and then to use those data to inform an analysis of threats to the key habitats. This comes from the 8 required elements for state wildlife action plans as published by Fish and Wildlife Service. So how every state agency does this is really fairly flexible. However, these are required elements of all action plans. And then briefly, our audience. So who's our audience and what level of information are we going for here? This is really meant to provide a high-level overview for folks who are working in policy review or maybe generating policy at the state level for, again, partnering with our sister agencies. And also, it provides some context for when we report out at the end of the year to the governor's office, or when we work with BLM or NRCS or the Forest Service to aggregate our data. It's not really meant for detailed site-level planning needs, but there are portions of it that can really assist with that. And then the brief 2 minutes of philosophy. We use biophysical settings to map the key habitats of Nevada. It's important to note that biophysical settings don't represent existing vegetation on the landscape, but we chose to look at what the landscape could have supported so that we had a starting point for comparing the current landscape and current vegetation of Nevada to past conditions. So biophysical settings, again, and stop me if you know this, but vegetation assemblages or communities that the landscape could have supported roughly pre-European settlement. And so again, we're using this to quantify what's now on the landscape, as well as to discuss past and future change. We're not really using these data to manage to baselines, though, and that's kind of an important point. That's probably more of a traditional manner that agencies have, and in many cases still manage to, especially in a restoration setting, which is a big part of our job. But we're really using this, hoping to use this again to kind of talk about past, current, and future change. So the first step in this process was mapping our key habitats. And again, you can see our finalized map on the right-hand side, but we needed to map to a management level, which is to say we needed to take the roughly 97 biophysical settings or vegetation communities that are mapped out by LANDFIRE within the state, and to aggregate those up to a level that was easy to discuss at a policy level, and it was easy to report on. That really involved some fairly straightforward work, mainly a crosswalk of the tabular data for the biophysical settings, and then going through comparing the individual biophysical setting descriptions to aggregate similar vegetation assemblages into units that were meaningful to us at a management level. We did have some starting points. We incorporated some previous community types that we've used in prior products and that we tend to discuss. So we knew that we wanted to, for instance, group up the high elevation sagebrush or low elevation sagebrush or aspen woodlands, which are very, very important ecologically here and have a number of threats. And, you know, I haven't really mentioned this, but each biophysical setting, again, it comes with a description that's based on a state and transition simulation model, and the LANDFIRE staff can tell you much more about this than I can, but it's those descriptions of the potential vegetation assemblages that we really went through individually and used to do this crosswalk. So that's, again, kind of crosswalking on a spreadsheet and then feeding that information into desktop GIS and doing a pretty straightforward spatial reclass of the rasters. So there were a couple of minor challenges with this process. You know, there are some minor element occurrences, some minor biophysical settings that occur in the state that you know, probably won't be addressed further in our products because either they were missed classes, especially along the Sierra front, or that kind of small thing. Particularly one issue that challenged us here in Nevada, because we're a very dry state, is the abundance of barren and sparse pixels on the landscape here. And so you can see a number of the gray areas, for instance, if you can see my cursor, are very large playa systems. You actually can't see some of the playas down here because we've subsumed those within the Mojave Warm Desert for other ecological reasons. But those do show up as barren and sparse on biophysical setting models. However, we kind of care about breaking those out, and we have a number of requests from our biologists and partners to break those out into things like playas and ephemeral pools, or sand dunes and headlands, or cliffs and canyons. So we're most likely, one of the next steps that's not presented here is using some of the ecological classification system information from NatureServe to actually go back and mask some of these areas out once we figure out kind of the spatial match between those. Here you can see an example of a crosswalk between the biophysical settings on the right and our key habitats on the left. And so, for instance, you can see our alpine and tundra. We subsumed 4 biophysical settings to that area. Aspen and woodland subsumes 2 biophysical settings. And I'll return to that in just a minute, but I guess we can see.
Can I?
Yeah.
Sorry, you just said save the question till the end, but I have a quick question.
No,
sorry.
I was going to actually say that's.
Okay, so when you do a crosswalk, are you in Excel, or are you in Access, or what are you using to just kind of basically do that?
Yeah, so our basic workflow here was just exporting the table from ArcGIS, going through and doing the crosswalk in Excel, because it's very easy to work there. I don't have to use an Arc editing session, for instance, and then I can add new columns. And so essentially, yeah, it's going into Excel, adding a new column for our key habitat, doing a one-to-one crosswalk. So each, this wouldn't be merged in this manner. There would be an individual row where I would have alpine and tundra repeated multiple times, for every single biophysical setting. And that allows me to keep notes and other things in there as well to send that out to review for staff along with the biophysical setting descriptions so that other people can review that. And then we pulled that table back into GIS and used it in the spatial analyst reclass tool. And if anyone has questions about that, I can walk you through some of the process that we used at any rate. And yeah, please don't save your questions for me. And so here's the final map, just with a larger legend, so you can see everything over here. I will say the springs and perennial river systems; those are different data. The springs come from the Spring Stewardship Institute, and the perennial rivers are a reclass cut down of the National Hydrographic Data Set. But all of these other habitat types here are ones that we subsumed from the biophysical settings. And here's a zoom in, so you can kind of see the northeastern part of the state and kind of the resolution that you get from some of the mapping products. So, if you're working in a more regional scale, you have maybe a little bit more need than that. And so the last thing that's really important about this process is that it then allows us to generate some tabular data and some kind of rough descriptive statistics for each one of our key habitats. So that, and there's a little bit of slop in this because it's coming from a 30 by 30 meter grid cell, but it allows us to get some rough calculations of acreages and the percent of the state that's represented by each habitat. And more importantly, that allows us to generate some really nice graphics for our action plan so that we can share this with people who maybe work at the state legislature or the governor's office or other places around the state who are involved, but maybe don't think about these things on a daily basis. And so, we can talk about the importance of low elevation sagebrush dominated shrublands to the state and why the loss of those is so critical. Or frankly, we can talk about the importance of relatively minor element occurrences like aspen woodlands and why the loss of those is so important because of species reliance on those systems. So that's kind of the overview of key habitats and how we generated the map. I guess before I move into discussing relative conditions, does anyone have any other questions?
Feel free to just unmute yourself if you have any questions. We're informal here.
And running a little slow. So describing the relative condition of the key habitats, we use the S-class data generator from LANDFIRE to do this. So now we're bringing in representation of current vegetation on the landscape. On the right, you see the S-class data flipped to Nevada. S-class or successional class data incorporates a number of metrics, including species composition, cover, and height. And it also, importantly, allowed us to map uncharacteristic vegetation, including exotic exotic vegetation cover and conversion to agriculture in urban areas. And just quickly, I'll point out this red on the map is uncharacteristic exotic vegetation, and it's probably an underrepresentation of where we are today. But that's very important for us here because we have a number of issues with invasive annual grasses and fire cycles that have really increased as a result of climate change and other anthropogenic disturbances. So the workflow for this is really where it got more complicated for us. It involves spatially joining the biophysical setting layer to the S-class layer and making sure that biophysical setting model and our key habitat data were retained in that merge. And then there's a lot of back-end data mugging that we did in our to merge the output of that spatial join with reference condition table and other data. And that reference condition table comes from the biophysical setting state transition simulation models, and it essentially gives us an idea of what the spread of vegetation across relatively young to relatively older classes would be. LANDFIRE staff know more about this than I do, but just briefly, each one of these biophysical settings is constrained to 5 S classes, I believe, and then the current S-class layer also has, you can see the native, uncharacteristic, exotic, and then other non-vegetation kind of classes along with it. So again, if anyone's really interested in this, I'd say Randy has been a massive help in Corey as well in getting this piece done. I've got code that I would be willing to share, although it definitely needs a thorough eye. But the challenges in this really would be, from our perspective, the lack of zeros in the S-class layer for settings that don't occur in an individual pixel, and then dealing with NA model codes for barren, sparse water ice, and just making sure that everything is matched up properly between the layers. And then you have to do a little bit of completing data tables or data frames to make sure that NAs in the reference condition table or no reference data values from the reference condition table are completed. If that doesn't make sense, feel free to pay me in that one after. So yeah, it's a lot of work to get that done, but the good thing is that once you get to the end of it, you've got really useful stuff. So here you can see some output that directly comes from some code that Randy shared with me, and you can see current status of key habitats within Nevada. And here we're looking really at conversion to non-natural vegetation, agriculture, urbanized areas, or barren and sparse areas. And you can see, for instance, the riparian and wetland systems within our state really have a lot that have been converted to either non-natural vegetation or agricultural areas. And then other areas like our desert grasslands have lost quite a bit of acreage to urbanization, for instance. And so these data here include areas that are vegetated, probably historically based on the biophysical settings. It doesn't include the naturally barren or sparse areas. And for our state, that's okay. We have really slow pediogenesis, and I looked through the data and didn't really see much change or conversion of barren areas to vegetated areas. So I decided to stick with not including those here, but it does mean that you have to be a little careful about the way you talk about it. But this has been really useful for informing our discussion of threats to ecosystems. It's been kind of at a high level, especially when it comes to anthropogenic disturbance. And it also allows you to dig in a little deeper to the relative condition of biophysical settings within the key habitats to really dive into a more detailed discussion about threats to an ecosystem. And so briefly, this is Intermountain Basin Big Sagebrush steppe, and you can see there's quite a bit that has been essentially anything above the meridian here is an increase over historic, and anything below is a decrease over the historic modeled. And so you can see we've had quite a bit of increase in exotic vegetation and uncharacteristic native. We've also had a real decrease in younger stages. And that, when we interpret that based on biological knowledge of the system is important to us because we know that a number of species that rely on this ecosystem really like a patchy network of different age classes. We're really not seeing regeneration of younger age patches here. And the kind of same thing here, just as a second example for Intermountain Basin aspen mixed conifer forests, we've had a real increase in older stands and a real decrease in kind of these middle age and younger stands. And so what that really might tell us is that we're seeing a lack of recruitment over time. And we know that from other studies and other knowledge of the ecosystem. So again, it kind of gives us a baseline to talk about these kind of like growth patterns to folks.
Hey Lee, in the previous slide, what would you attribute the one before that? What would you attribute the role of fire to those younger succession class in the sagebrush ecosystems?
Yeah, well, I think, certainly the role of fire and cheatgrass is pretty obvious here. And these are slightly higher elevation systems than the Wyoming sagebrush, which has really been hit by fire and cheatgrass. A lot of this, it's frankly, for some of these systems, really hard to tease out whether this is improper grazing or feral horses or some other issues that might just be leading to a depletion of the understory, which is really largely what I would attribute this to, is like a lot of older sagebrush, but older sagebrush that's lacking perennial. Well, actually, I'm going to hold back on that because these data don't really address that. We can talk about that later, but I don't, without overlaying fire on these, it's hard to say. That is a thing that we can do, though, is we can take the S-class layers and we can overlay fire polygons, and that's one thing we've talked about doing. I have not done that yet, so I'm a little hesitant to say, but yeah, certainly cheatgrass and fire and really other management issues that lead kind of to overutilization of the landscape by both native and mostly non-native ungulates is probably a really big thing. But it's also worth saying, and I'm going to hit this in a minute, that sagebrush is an episodic recruiter. You'll get really large flushes of recruitment, both seed set and recruitment of young individuals kind of through the age classes when we have good weather conditions and near the middle of very long-term drought, with every indication that soil water availability and other important kind of secondary indicators for plants, if you think about it from a climate change point of view, going to continue to probably impact recruitment in these species. Now, actually, I'll hit on that in just a minute if you don't want. So yeah, kind of the what else now. One thing we're working on right now is working with Patrick McIntyre and Pat Coomer at NatureServe to run a habitat climate change vulnerability analysis for some of our largest key habitats, and by largest, I mean in terms of extent on the landscape. So low elevation, high elevation sagebrush, for instance, Mojave Warm Desert, some of those really large ecosystems. We're also doing a handful of the smaller ones like the aspen woodland, just because they've been identified as kind of critical to species utilization by the department. That product looks at really potential exposure to climate change and potential adaptive capacity of really at the biophysical model level. Without getting into details, because I'm kind of digesting through this as well, but hopefully that will let us look at the potential impact of a changing climate on some of these key habitats as well. And I do want to say a massive thank you to both Nature Conservancy and the Southwest Climate Adaptation Center for helping us support and coordinate that work. So some of those pieces, Megan, are kind of coming as our next steps, kind of trying to tease out the impacts of different things. I'm going to say we're also using the output, the key habitat output for some of our other products. This is something we just finished in conjunction with the Origin Sagebrush Conservation Initiative. It's rangeland analysis platform data, but it shows relative abundance of cover between functional groups like shrubs, perennial grasses, annual grasses, and forbs. So the underlying data are from another system, but we've masked it to the key habitat that we generated for low and high elevation sagebrush. So we'll continue to feed these habitats into other products as we come down through the next few years to do more other kind of planning analytics, so we can kind of have a common language for our reporting. And I did rely very heavily on these references from Corey and Randy, so I just wanted to put them up here because they were very, very informative when it came to working on some of this. Yeah, with that, it's kind of a broad overview. I know I kind of did my best to blast through that and not take too much time, but
thanks, Lee.
Questions. Yeah.
Appreciate that. So now is the time for anybody who has questions about specifically about Lee's work or your own work related to LANDFIRE. Please feel free to go ahead and chime in. Looks like Eli is going to get in touch with you, Lee, directly because he has some specific things to chat about. But anyone else feel like chiming in?
So I will maybe kick things off. I've had the luxury of working with Lee and kind of following along as he's done this work. And so it's been so great to see it coming together, Lee. You mentioned early on something I'm going to probably try to remember to quote, which is you're not managing the baseline, because I know that we've got, different values and climate change invasives and everything that we have to manage around. I wonder if you have ecosystems that where reference conditions are more equal to resilient conditions and ecosystems where reference conditions are just nothing like current or nothing like what you hope the future would be. That was probably an awkward way of asking that, but I'm just wondering, like, reference conditions sometimes might equal resilient and sometimes not. And I'm wondering, like, what you're finding out there in Nevada.
Yeah, that's a really large question here. And I will say that many state agencies, ours included, are really just moving towards thinking about not managing to reference condition, right? And when you think about it, what we're tasked with doing in many ways is trying to either conserve current habitat or conserve current species ranges or conserve T&E species. And so our approach is very much, if you're thinking about it from a resist, accept, direct framework, it's very much resist. Done very little thinking in terms of direct. So I think we are finding that on the landscape. There are certain places that are much more resilient, resistant to change. That's certainly a very common framework that's employed here, piloted really by Jean Chambers and her peers at the Rocky Mountain Research Station. And so we do find that, at least currently, given that Nevada has a very large climatic gradient, both elevational and latitudinal, and then we have a number of very bizarre soils, which leads to a high level of endemism in plant species. We see that some areas are really, really changing very quickly. Wyoming big sagebrush at relatively lower elevations, for instance, has been very impacted over the past 20 to 30 years, whereas montane sagebrush systems have been relatively unimpacted, or even blackbrush sagebrush systems down at the Mojave Great Basin ecotone further south than us are actually doing relatively well, probably because a number of those populations and ecotypes are really adapted to arid conditions already. So yeah, not the hedge, but I think that's kind of where we're trying to look.
Yeah, thanks for those thoughts, Lee. I know it's a kind of a tough question, but I was just curious. I'm trying to kind of, in my mind, build a bit of a framework for that myself. So I appreciate that.
Sure.
Thanks so much for your presentation. You've just climbed a huge learning curve for using LANDFIRE data over the last few months, and I'm wondering if you have any feedback for us. Is there one thing that was like kind of a stumbling block maybe for your team, or that was difficult to understand, where LANDFIRE could have done better, maybe with having more support materials or something to help you kind of get over that challenge?
Yeah, and thanks for that. Because I will say, your willingness to actually work with me on this helped me through a lot of those technical issues. I think I'm not sure how common this type of use case really is for LANDFIRE data, but really pulling together the S-class information is the most difficult thing, just because of the format of the data. And it wasn't certainly a game stopper by any stretch. I think, my questions now at this point, having worked through this for the past few months, is just making sure that we're using the data correctly and talking about it in the correct manner. But also, now on the back end, I have a lot of questions about the STSM process and how to use potentially the data to inform forecasting under climate scenarios and those kinds of things. And I don't know how many questions you get about that. Yeah, I mean, it's not necessarily straightforward to use it all, but it's also not insurmountable by any means. I don't think I answered your question.
I put Corey and Randy's email up there in the chat, so if anybody wants to get in touch with them, for better or worse. Sorry, Corey. Sorry, Randy. No, just kidding. That's what we're here for.
That data format challenge, Lee, that's a really interesting one, and I appreciate your comments on that. I think that we don't often think of what the person getting the data is going to do next, and we might present the data in a way that's a little easier on the eyes, but harder for working with. And I think the S-class data might be one of those where it's formatted so it's easier for us to look at and review, but then when you want to make a chart or doing analysis, you have to pivot longer and do all these things to make it work out. And then, it's so we rely on people like you for feedback, because we just are so used to dealing with it that we're numb to it, or we don't even notice it because we're not doing the same things that you were doing. So.
And actually, yeah, thinking about that, I did have a little more feedback, Corey. I think, yeah, Randy, to your point, I actually kind of get why if the data are the way they are, I'd probably generate it the same way if I were to format it that way. But I think one of the biggest challenges for me in the beginning to work with the data was honestly trying to understand how LANDFIRE fit in with previous efforts, like in particular the crosswalk between LANDFIRE and Pat Comer's ecological classification work, and how that all fit together, and how maybe map zones, which we didn't really talk about, how map zones might be different from or informed by other kind of eco-regional products. And I think some of that information was a little challenging to either find or pull together exactly. And so I'm not sure that I always exactly understood that, and it didn't really present an impediment to using the data, but just from a personal curiosity standpoint, I think that was a little confusing at times.
I'd be curious if anyone else on the call has experienced the same confusion, or because those are fair criticisms, and we're always looking for ways to, clarify and expedite people actually being able to use our products.
I see that Carrie put a really good question in the chat. And fire return.
So this is Carrie, and
Hey,
I
Carrie.
noticed that its use at a broader scale looks incredibly interesting and very useful. I'm kind of wondering for my planners, at what scale are they kind of abusing the system when they plan? Because they might be planning on small acreages.
Yeah, exactly. It's a really good question. We don't have a set answer, you know, an absolute scale at which we say you can use it or you can't use it. What we recommend is that people review the data for their area and decide if it's appropriate at that scale and for their application. So I know that is a little squishy, but the sort of the mapped the accuracy of the mapped classes will vary by area. And so that's one reason it's hard to make blanket statements. But there are also a few things that people can do if they review it and find, you know, that it's perhaps maybe doesn't meet their needs exactly as is. So one of the really easy things you can do is what Lee did, where you can lump systems. Oftentimes we find that LANDFIRE is mapping at a finer level than people are managing to. And so grouping like systems sometimes helps. And then the other thing I would say is just, you know, well, what other data do you have? If you don't have any other local or better data, LANDFIRE might be the best that you can do. But we always encourage people to review and revise as needed. Jim's the real expert on this. We'll see if he wants to chime in too.
Sorry, I was muted. Yeah, and it is a very, very important question. I wish that we could say 100 acres or 5 acres or 1,000 acres or whatever. But it's just impossible because, as Corey said, it's so different in different places. And normally what I ask people to do is to sort of start at a landscape level, whatever you would call that, a Huck 12 or a Huck 10 or whatever is a landscape to you smaller. And then you just review it and you have to start looking, zooming in on it to see how it's doing. Is it at some point, all data sets fall apart, LANDFIRE included. So it does require local review and effort to really understand how well it applies to landscapes out of the box as delivered. And one of the things we've done is we've actually worked with people. So if you wanted to say, get on a call and we share a screen or whatever, and we look at it with you, then we would certainly do that. But we can't provide you sort of a definitive answer. And I'm sorry to say that that's the truth, but it is.
Well, like our web soil survey, we tell everybody this is the starting point in planning. Now you go out and you try to determine how far this point on the land is to the perfect situation in that polygon, right?
Yes.
And like the soil, you know, vegetation is, we draw lines, but vegetation is transitional and like the soil. And I guess my other question to you folks would be, have you looked at soil surveys in comparison to the vegetation? And when we do our mapping with the soils, we include vegetation and of course we do lines as well, and lines are, you know, drawing lines on a map really isn't true because of things being transitional, but we know that many different types of soils can produce a similar vegetation. And I was just wondering if you've done any of those comparisons, I guess.
Harry, I will answer and say I'm not really sure. We have done some comparisons to ecological site descriptions, for instance, you know, which are soil related, but how soil are used in the production process. I see that Inga is on the call, and she might be able to give a more definitive answer. She's the technical lead for LANDFIRE with the contractor at Arrows. So if you're able, Inga, can you answer Carrie? Do we use soil as an ancillary variable in any of our map production process?
We do for EVT. We use the Sergo gridded data.
It was also used in BPS. So StatsGo is used to map biophysical settings.
All right. Thank you. I appreciate it.
Along with a lot of other variables like growing degree days, precip, aspect, elevation, slope. But sometimes the soil data can be a little bit of a limitation.
Because it's at such a broad level.
Yeah.
And at least some of the data sets varied a lot from state to state, Carrie, in terms of the quality and how they were done, since they weren't done by state. Sometimes different things were available at different times were done better in some states than others. So it was a bit variable.
Oh yeah, it's an ever hopefully improving product, and yeah, the older surveys were a lot broader than the newer surveys. So yeah, absolutely.
Amen. Ever improving. That's our motto too.
Great question. And I'm thinking, Megan, I think it's I need to supply you some tweets. I'm a little behind on that, but I would love to ask our Twitter followers if they've done that. I think it's a really interesting question, Carrie, just to see how our types line up with soils. I'm sure somebody's tried that for some place just to see, look for the patterns, just for exploring sake.
Well, I expect all the arguments are going to be along those where we draw our lines. But I think, yeah, it would be interesting to see.
Carrie? Yeah, Tim Hatton here. Just so you know, I in the past I did some species distribution modeling for bumblebees throughout the Pacific Northwest, and I did pull in the Sergo data and existing vegetation type layers from, at the time, GAP, but that's essentially LANDFIRE data as well. And I'll just say in general, there are some very strong associations between, EVT and those soil map units. It's going to vary, obviously, and you got to dig into it, but it's not surprising how much, those soil types drive plant communities. There's some strong associations. You'd have to get into it, though.
And have you all been making any adjustments or predictions as to how things are going to shift with our changing weather patterns and climate? I mean, that's a big question, but just wondering.
I would say, Carrie, LANDFIRE does not do that. But, we probably have supported people who are looking into that. Randy, climate variability. I think the next step for Lee, that Lee Davis is working on is, climate change vulnerability, Carrie. So we're supporting him in that, but the program itself does not supply any information about how, say, species ranges are going to shift, or, fire return intervals are going to change, or any of those kinds of things. Those are sort of post-delivery analyses done by other groups, enterprises, etc.
The LANDFIRE is mostly benchmark conditions, how it's been.
Well, that's the biophysical settings layers are, and then there's a set of current as well. Anything with a existing vegetation type or cover, etc. Those are all current, but they're not projected into the future.
Okay. All right.
There are some fire-related systems that will project into the future. One called IFTDIS, Interagency Fuels Treatment Decision Support System. that actually, you know, you can actually, there are some things you can do to project, but we do not do that as a program.
Okay, thank you. I appreciate it.
I can also put in the chat a link to a website the Nature Conservancy's LANDFIRE team developed in collaboration with the USGS, where we talk about our biophysical settings models that are very similar to ecological site description models that NRCS produces, their state and transition models. And on that website, we talk about how you take one of our biophysical settings, which kind of represent a historical condition, how you could bring it to current, and then how you could then use it to project into the future. So again, like Jim said, it's after the fact, it's not something LANDFIRE is doing, but it's something that users can do. And we do have some information online about that.
Thanks, Corey. I put that link in there. We are almost completed with today's office hours. And before we say goodbye today, I wanted to launch the evaluation poll. We can definitely stay a little bit longer if people have further questions. Usually we schedule about 45 minutes, but more than happy to stay longer if folks have more questions today.
I just wanted to add, I think, yeah, with the existing vegetation, we sort of indirectly have been incorporating, you know, sort of the recent changes to average temperature and precipitation. So, yeah, I mean, when we put in those values, you know, those are kind of reflecting more recent climate.
I guess before we go to, I want to say thanks to everyone. And this is the first time I've run through this presentation. So if you have any critical or constructive feedback, please let me know. But definitely got to get it cleaned up and in front of a few folks in the not too distant future.
Well, if this was your first run through, I think you're doing greatly. So thanks. And folks, feel free to scroll up in the chat window and grab emails or links from folks before we sign off today. We still have plenty of time if people have burning questions. Maybe this might be a good time, not to put anybody on the spot, Henry or Jim, but it seemed like Carrie, it might be useful for us to talk about the update that's coming in June, what sort of data can be expected to be included there, just to give people a quick rundown.
I'd be happy to have Inga or Henry answer. I've already talked a lot, but
okay.
Is Henry still on?
Yep.
Yeah, I'm on, but others can go. Inga can share.
Yeah.
So go ahead.
I probably won't remember all of them, but there's quite a few updates. So, you know, we have all of the new infrastructure for 2020 in there. So things like developed areas, new roads. We have a separate layer that we're calling the operational roads. So that's going to be something that you can kind of burn in on top of other LANDFIRE layers if you really need more detail on roads. We have updates to vegetation cover and height using our vegetation rule sets in STSIM. And we have a little bit of change with we're kind of reducing the area of our developed rural classes because they were a little too broad. So we've got what's called burnable developed, which is kind of giving us a little less of an area of kind of that WUI. So I think we were a little too broad before. So now we're using the Microsoft building footprint to really get a little more detailed on, you know, where is the WUI exactly. So I think those are the major updates. We also had just released our topo, topography, elevation, slope, and aspect, which are much improved based on recent elevation data from USGS. So what else, guys?
The only thing I'll add, Inga, is that the delivery will be in June for CONUS, and it will reflect disturbances, landscape disturbances through 2020. So in this delivery, we'll be reducing our data lag to 18 months, where it has been 2 years or more in the past. So we're on the path to hopefully delivering annually, including the previous year's disturbance. But in this next version in June, it will reflect disturbances through 2020. Any kind of disturbances. And there'll also be anything, it's not just fire, it's treatments, it's, as Inga said, developments, it's harvests, it's insect disease, whatever kind of landscape
all the
change
agriculture.
Yes.
Right.
So that's an important thing to see, that we're moving toward a more current vintage product every delivery.
The only other thing that I would add, I thought you did a really nice job of covering the main high points and, relative to disturbances, is this also includes the 90-kilometer buffer in Canada and Mexico. Again, it's just going to be incremental progress. Going back to what Corey said earlier, we're always striving to make improvements. And so there's, I think, a lot more that could be done, but just to be aware that, I think, especially with this topic, thinking about wildlife and habitat, we know things don't end at a administrative boundary, say, United States and Canada border. And so when it comes to thinking about, modeling, cover and height and, the needs of wildlife and, habitat, having that buffer will be important in, considering analysis that may occur, near those so-called, border lines or administrative boundary lines. So that's another key point just to be aware of relative to the LANDFIRE 2020 update.